Alright, here's our question that says, if we've got this function, f of x equals 2x plus 3 over 5x minus 2, we're supposed to first of all find the inverse of this. Well, in order to find the inverse, we have to switch out the x's and the y's places. So if we rewrite f of x as just a plain old y, it makes it so much easier to see where the x is and where the y is. So now we can replace, instead of y, let's replace that with an x, and instead of an x, let's replace that with a y. So I'm going to do that in both places there. And now we have to solve for y in order to find the actual inverse function. So I'm going to multiply both sides by 5y minus 2, which will cancel that out of the denominator. And now I'm going to distribute as I go. So this will be 5xy minus 2x equals 2y plus 3. And then moving everything with y's to the left, everything without y's to the right, we'll have 5xy minus 2y equals, over here we have 3, and I'm going to move the negative 2x over to the right, so that'll be a plus 2x. Now we have a y in common, so we can pull that out, factoring it. So we have y times 5x minus 2 equals 3 plus 2x. And now dividing both sides, to get y alone, we have y equals 3 plus 2x over 5x minus 2. Now this is the inverse function, but it really needs to be, written properly. For proper notation, we have to write the inverse function as f to the negative 1 of x equals 3 plus 2x over 5x minus 2. There's our inverse function. Now we need to find the domain and the range of each, our original and the inverse. So our original function, in order to find the domain, we have to figure out what we cannot use in that original function. Well, we cannot use where 5x minus 2 would equal 0. So if I solve this, we have 5x would equal 2, or x equals 2/5. This is our hole in the domain. So for our domain would be the set of all x's such that x cannot equal 2/5. Now for the domain for the inverse function. The domain of the inverse function would be where the inverse function's denominator would equal 0, which is 5x minus 2, where that would equal 0. Well, that's the exact same thing, isn't it? So our domain of the inverse function would be the set of all x's such that x cannot equal 2/5. Now this one is a very strange one because both of their domains actually happen to be the exact same thing. That doesn't happen very often. What normally happens is we have two distinct domains, and then we use those domains in order to find the ranges, because the domain of the original is going to be identical to the range of the inverse because we've switched out the x's and the y places. So that means that our range here would be the set of y's such that y cannot equal 2/5. And then likewise, the domain of the inverse function should match the range of the original. So our original's range should be the set of all y's such that y cannot equal 2/5.